Hello, hello. Oh, welcome. Welcome again. My name is Daniel, and I'm going to tell you something about application architectures today. So, in the beginning, I would like to just mention quickly what's application architecture, why we should care about it, and how it can be beneficial for us. Then I'm going to go through the most common application architectures, which is MVC, MVVM, and VIPER. But probably since you've already seen a lot of articles and a lot of diagrams and images, discussions and whatever, so I would like to just show you or give you the opportunity to real-time compare these architectures. So I created this small application, which is basically one screen, which is downloading most trending repos from GitHub. And when you click on each cell, it will just show you some detail. But I created this application 3 times. One is following MVC, then is following MVVM, and the third application is following VIPER. So in each section of the presentation, I will show you how the project look like and how you can just be how it can be beneficial for you. So what's application architecture? Actually, in general, it should help you to have the project well organized. Be more scalable, maintainable, and testable, and actually it should be easy for your new team members to easily onboard on the project. But of course, there is no golden super universal application architecture, and there are thousands of attitudes and explanations. So it's kind of my excuse for me that today I'm not going to show you how to do it, how you should do it or how you have to do it. I'm going to just show you my point of view and what's my perspective. Of course, in general, be aware, and you should always care more about how you code it than what you are coding, because it can easily transfer your project into a spaghetti western, which you totally don't want to. So what is MVC? It means model, view, and controller. And the first is model, which is just representing some data for your views. View is just some dump item in your screen, which is just showing some data from the model. And the controller here is a quite smart guy who knows how to assemble the view, where to get the data from, and how it interacts with the user and many other actions. So now I'm going to show you how the project look like with MVC, which is this one. So it's basically just few files. In AppDelegate, there is nothing special. There is a main entry point in the storyboard. You just show the main screen, then downloading some data and go to the details. So which is here. In view edit load, we just sync some data, get the data from API, and when we have the data, we roll the table, and cell for row knows what cell it should populate with the data. So nothing special here. When you click on the cell, it opens the detail, and it just sets some label and title. So it's pretty straightforward, and you've probably seen a lot of these applications. So it's pretty easy. And kind of summary of the MVC is pretty intuitive. So when you show the project to someone, it will probably immediately know where the application starts and where it gets data from and so on. And it's easy to implement, not so many files, but it can lead to massive view control, because I've seen a few applications with view control more 2,000 lines of code, which is kind of a lot, and it can be worse. And the controller here is a superhero, so he knows everything about the application, about interactions, and where to go, and it's not really necessary. And of course, it could be hard to unit test or not so straightforward. So kind of natural evolution led to MVVM, where the flow is pretty similar. We have model, we have view, which is still pretty dumb. And we have view model, which is the smart guy here. He knows where to get the data from and how to handle user input and so on. But there is a small change, because the view controller here can be just understand it as a view. So it's just a stupid screen with some views, and you can just display some data from the model. But since it's getting more like complicated, there are probably some problems which could be faced during the development. So don't take viewModel as a trash can for all the code you probably don't know where to put. And don't use direct pointers, because a lot of viewModels can just join with particular UI elements in the view control, because it's pretty easy for you just to code, because you have kind of like extension of the view control, but it's not like ideal state, because you should understand the view model as like independent part. It can be theoretically used in a different project. It shouldn't know about your view control. And of course, like singletons, don't take them as a wise man. You know, it's just not like universal storage which is always accessible. So I like singletons, but not in this meaning. So for example, if you take these worst cases, you have view model, and it has pretty tight connection with the view control, with the table view in the view control, with some edit button, and of course we set some state in the singleton, which is totally bad, because it can lead to application to be totally confusing behavior, and you don't want that. So I'm going to show you the code, which is a little bit longer, but only one file extra. So still the same. There's updelegate, which just opens the main storyboard. There's entry point. Go to the list. But the list is asking for data. It's view model. So the view model knows about the presenter, not the view controller. He knows about the presenter. The presenter theoretically could be anything. And the view model just syncing data. So when we look at the view model just knows that someone asking for data. It just call API, getting the data, returning the data on the presenter. And it's through a protocol. So where is the file? Yeah. So when we asking for reloading data, it just reloading data on the table view. And when we click on the cell, it's just which is here. Sorry. It's just asking the view model to present the detail, or sorry, like yeah, it's here. So we are the view model. Sorry, someone is calling me. Damn it. So it was just vibrating my hands. I was kind of like, not focused. So back again to the presentation. We have real data, and we have hiding the load indicator. And when someone is clicking on the cell, we just present the detail, which is like very short action, which is here. So we just loaded the detail, and we set the data. Oof, sorry. So back to the presentation. What are the pros of MVVM? It's pretty intuitive still quite easy to implement. The logic is separated from the view, which is good. And the whole project is more reusable. What are the cons? And it could be confusing for new team members, for example, how to orientate in the project, but it's not that hard. And slightly more code than in MVC, but it's not like it's maybe more code in this small project, but if it's like bigger project, it's not like that. Well, VIPER. VIPER is it should be actually of peer, because the hierarchy is the view is connected to presenter and then interactor, not view interactor presenter. So it's kind of like confusing. But the view is still like pretty dumb, just UI element, just displaying some data. Presenter here knows about the, he knows about the view, and he knows who to ask to about the new data. Interactor knows where to get the data from, but doesn't know anything about like where to present the data or who's asking for the data. Then we have entity, it's still the same, just some container with data, and router here adds some kind of like guy who knows where is in the application, what he should display, and how to interact with the user. So let's go through the code, which is no, here. And it's a little bit more files, as you can see. So in Abdullah-Gate, it's a little bit different because here we have a root router who knows where to start or what to do in the application start. Here you should check for some logged in user or expired tokens or whatever. But here we just present the main screen, which is this code. So we know that in the beginning we should ask repo list router to assemble his module, which is here, which is just creating some view, which is a repo list view control in this case. Then we create the presenter, interactor, and the router itself. And in this particular case, we know that we should start with navigation control. So we created that. Then we assemble or set the structure or the dependencies, and returning the navigation controls. And the application itself starts, of course, with the repo list view control, which is this one. And when it's displayed on the screen, it asks, or because it doesn't know anything, so he's just asking his presenter what to do, which is updating the view. The presenter knows that when someone is asking for data, which is here, he should display the loading and then ask interactor to sync the data or get the data. The interactor knows that if someone is asking for data, he should call API and get the data and then returning to the presenter. So we call the data, and the presenter here knows that when he get the data, he should inform the view with the data and reload the view. So it's here. Yeah, we know that when we have the data and we should reload, we're just calling the same as in the previous cases. So we just reload the table view and the presenter knows or presenter has the data. When someone is just interested in the repo and clicks on the cell, we always ask the presenter what to do because the view itself doesn't know anything. So the presenter knows that when someone clicked on the cell, we should do something which is, yeah, here. We should ask router because we know that the action should lead somewhere. So we asking router to present the detail. And the router knows that when someone is asking to present the detail, he should ask the detail router, which is the separated module, which is just the detail, to assemble his module. So we create the module and present it on the view control. So assembling the module is here. We are creating the view, which is detail view control. We set the dependencies and the models, interactor, whatever. Here we are not creating the navigation control because this router knows that the detail is just part of some navigation, so he doesn't need to create the navigation control. And then we are just returning the view control, which is the detail, and the repo list knows that he should push something which went from the assemble module, from the detail router. So the detail screen is right now displayed, and of course, again, he doesn't know anything, so he's just asking his presenter to update the view. So the presenter, detail presenter is here, and he knows that if someone asking for the view or for information for the view, he should set up the control with the data which he got from the previous router. So he just updates the view, which is here with the view, with the title and description. So that's it. Did it make sense? Kind of confusing, but in the end, it kind of makes sense. So small Silicon Valley insights. As you probably heard, Uber application was written originally in Objective-C, but they decided some time ago to rewrite the whole application to Swift, and they decided to use VIPER. So it took like several lead engineers just to plan the application, the whole structure, how it should be done, and so on. Then it took several senior engineers to to implement the core application, like the interfaces, to design the whole communication and all this stuff. And then to at least maybe more like the rest of the company to just finalize the project. So, animations, getting the data, the real coding. So in general, the numbers, it's 5,000 files, more than 5,000 files. So when you open your application, it's like that. It's more than 500,000 lines of code, and the compile time is pretty huge. So in the beginning, they were talking about like 40 minutes of compiling. Then they tried to like push it down to just several minutes, which is still kind of a lot. So what are the pros of VIPER? Of course, the name, which is pretty tough. The scalability and the logic is totally separated. So each member of your team can work on the separated module, and they don't need to like interact with each other. And test-driven development kind of makes sense right now, and it's pretty easy. But cons, of course, like when you saw this application, it's pretty small, but it's a lot of code, a lot of protocols, a lot of methods, and could be confusing when we have really like the big project with all these, location services and all the stuff, core data and whatever. And not really like, it's not for everyone. So to have someone to screw your project, it's pretty easy. So what's the conclusion of all the architectures? Always try to keep it simple, because when you over-engineer it or overthink it, it's pretty tough. Think abstract, because when you try to think about your project as a separate, Lego parts, it's always good. And try about testing, because when you're always trying to think about testing of each part, maybe it can help you to design whole part in a different way. And of course, it's about project, because not every architecture is tailored for each project. There is no like super universal architecture, as I mentioned. So it's always about a project. For example, I'm using MVC when I just need to really fast, prototype the application for the client. And then when I know that this application will be, deleted in a few days, so that's it. But of course, I've never used VIPER for client's project, because the project will be kind of complicated, and the client won't be pretty happy in a few days, because I would need to still spend a lot of time just about designing, and the client just doesn't know like few weeks that if something is going on, or I'm already left the company or city or country. So kind of my favorite is MVVM, and of course from reasons. So I will end up my speech with this quote, which is, there is nothing either good or bad, but thinking makes it so. So when you overthink it and over-engineer it, it can make your project pretty bad. Right, thank you. And if you have any questions right now, it's time for that. Wanna go to the last screen? Oh. Right, guy right there.
From your presentation, I didn't get the difference between MVC and MVVM. It looks like same. You have 3 pieces on one graph. After that, you change graph little, but it's still 3 pieces, and it still do kind of same stuff.
Well, of course, like this example was just getting data from API, so just one function was moved to view model. But in general, the whole logic of the view control should be moved to a view model. So, and the view model should be connected with the view control only by protocols. So, the main idea would be to use the view model in a separate, parts of the application without no pain. So here, of course, it's very stupid, and we can just do MVC. It's maybe even less lines of code. But in general, the idea is to have the logic separated. So when you create test, for example, you're just testing the view model, and the presenter is your mocking test object. So yeah, of course, here, for example, it doesn't make totally sense to make VIPER because the application is a mess, and probably none of us would would be able to extend the application. But in general, the MVVM is the idea is move to view model. So the view control is just displaying some stuff, and the view model doesn't know actually where it's displaying the data. It's a repo list or it's user profile or whatever. It's just displaying some data somewhere. So of course, it's the problem of the examples because it's always small code, and it's in math class you just have some dividing and it's always 0 or 1, but in real life it's 1.7 thousand, so it's kind of problem of examples.
So your view controller do all mapping from view model to view outlets?
View control make all the mapping to?
Yep, mapping the data from view model, not map, connect data from view model to outlets.
No. That's the logic itself means where to get the data, where to display the data. But the view, the connections to view, the view control holds the pointers to labels and so on. So that's why you have your protocol. You have show loading, but you don't know where it's showing. Is a red line of some text on the top, or it's a alert view or whatever. It's just show loading. And the view controller knows what does it mean to show loading. So it's kind of logic of view, it's in the view control, but logic of the application, it's in the view model. So the view model is just doing the logic. So it's just saying, okay, I have the data, here's the data. Or someone just clicked on something, so I should do this, not do this. Does it make sense?
Yes, it makes sense.
Okay.
But
Right? Anyone else? Familiar faces?
Thanks. You have mentioned this issue with your stakeholders that you have to show something in some time, some planned time. How do you leverage this? I mean, you have we have seen these pictures from VIPER, and there were designers. They were designing this kind of VIPER architecture. Several months, several engineers, and I mean, is it possible to just build some basic, very basic concept or very basic architecture, and to scale it on the fly? Is it possible with this VIPER concept? I mean, is this enough flexible for the requirement from the stakeholders?
Yeah.
Because it can be a sort of abstract hell, because you want to be flexible enough, because they have one month they have this kind of requirement, another month this kind of requirements, and if your project owner is not assertive enough, it can be really you try to use abstraction so much that it's not healthy.
Yeah, sure. It depends on the client or who you should do the presentation to, because when you're deciding to do VIPER, there needs to be really strong opinions or guys who just deciding, okay, we need VIPER because of this. So probably you should explain to the client that you're using VIPER to make the project and the product scalable in 10,000 years in the future, and not just next few months of investments. So that's first part. Second part, of course, it's hard to present something very fast because, as I mentioned, it's a lot of time spent on designing. So probably you need to. It depends what's enough for them. So of course you can always do something in storyboards and show some images, and it could be enough. But if you need to show the real functional application or at least some stupid application, of course you can just ignore some parts. For example, interactors are just the guys who are just getting the data from somewhere. So it can be some mocking data or some, or you can ignore them at all actually. So you always have like the view, you have the presenter, and the presenter, like, that's it, you know. Then is asking the router to go somewhere else. But you can just save some time on not implementing the interactor, for example, or having some very dumb entities because you don't really need the data. So it depends like what's enough for whoever you need to do the presentation for. So yeah, that's. Anyone else? Of course, you can just, you know, ping me up there and we can talk about it. Oh.
So as I understand, MVC, MVP, and MVWP
MVC, MVVM, and VIPER
can be used just to solve routing problems here, because they're just GUI architectures, like graphical user. Yeah.
Kind of not catching the idea.
We could use routing problems just with VIPER architecture, yeah?
Well, actually, like, you can take the router and put it into MVC, so you can just, you know, like, the control wouldn't, like, do the action by itself, you would just ask the router. So you can actually implement, you can take the best advantages of VIPER and put it somewhere else. So, like, it can help you, of course, but, like, the pure VIPER was like the thing I presented.
Okay, thank you.
All right, thank you very much. Enjoy the night.